Hi everyone, welcome back. Let's talk about condition of a matrix. A computational problem is ill-conditioned if its solution is very sensitive to small changes in the parameter that define the problem. So we can use a condition number to describe this sensitivity. Given a matrix A, the condition number equals, so K of A is the L1 norm of A times the L1 norm of the inverse of A. So we can use other matrix norm such as L2 norm, L infinity norm, and the Euclidean norm to define the condition numbers. So this is the L2 norm. Okay? So if the condition number is large, then we say the matrix is ill-conditioned. So the solutions is very sensitive to small changes in the parameter. Okay, so if Ka is large, we say A is ill-conditioned. Okay, and usually if we calculate using the L1 norm, if the condition number is large, then when we use other norms to compute, the condition numbers are also large. So even though they might not be the same number, but they're both large. Okay, they're both large. Let's look at the following example. All right, consider the linear systems A equals -2, 3, and -1.999 and 3. So part A, solve the system when B equals 4, 3.999. What does that mean? So sometimes to save some space, I type this, but I mean it's 4, 3.999. This is a column vector. So this is a row vector, but when you transpose it, then it is a column vector. Okay? And let's solve it. So what is the arithmetic coefficient matrix? -3, 3, 4, -1.999, 3, and 3.999. Okay, so first step, we want to make this one and then use that entry to Q the entry below it. But here, we have to divide it by -2 of R1 because this guy is more complicated, right? So even though we try to avoid fraction, but in this case, we have to do it. Then we have 1, and this is -3/2. 4 divided by -2 is -2. And then the second row stay the same. Okay, and then we can now use 1.999 times row 1 add to row 2. Then the first row stay the same. The second row, 1.999 minus 1.999 is 0. Okay, for the second entry, okay, let's use our calculator. So we do -1.5, 3/2 is like 1.5, times 1.999 plus 3. We get 0.0015. So far, so good. The next entry, we have -2 times 1.999 plus 3.999, and then the answer is 0.001. So the first column is the coefficients of x1, second column is the coefficients of x2, and then the last column is the right hand side. So the last row tells us that 0.0015 x2 equals 0.001. Well, let's both sides multiply by 10 to the 4th. Then we have 15x2 equals 10, right? So x2 is then equals 10 over 15. The common factor is 5. So we have 2/3. So far, so good, everybody? Okay, and then we can plug in the first row. First row tells us that x1 minus 3 over 2x2 equals -2. So let's move 3 over 2 x2 on the other side. It becomes positive, and we have minus 2, and x2 is 2/3. Ooh, you see they cancel. We just have 1 minus 2 is -1. So the solution equals 2/3. Oops, no. x1 is -1. Yeah, so be careful. And then x2 is 2/3. Yes, check our answers. Okay, so that is part A. Let's continue with part B. So let me change a different color. Okay, so part B, we're gonna solve the system, but we just change it a little bit. Instead of 4, we have 4.1. Let's see how this will change the process. Well, the operation is still the same, right? This is 1 minus 3 over 2. Okay, 4.1 over -2, that will become minus 2.05, right? And then the bottom, we still have the same. And we can still use 1.999 times row 1 add to row 2. Okay, 1 minus 3 over 2 minus 2.05. Here, we still get 0. Here is still the same. But this is gonna change. What number it changed to? We do minus 2.05 times 1.999 plus 3.999. The answer is minus 0.09895. Minus 0.09895. So far, so good, everybody? Okay, and then let's see. This is x1, this is x2, this is the right-hand side. Last row tells us that 0.00, 2 O's, 15 x2 equals minus 0.09895. Well, then x2 equals minus 0.09895 divided by 0.0015 approximately equals to, let's use that answer, divided by 0.0015. Okay, minus 65.97. Or let's use more digits. 666. Actually, the 6 is repeating, right? Okay. Because we know it's repeating, let's just put a bar right there. So far, so good. And then to find x1 minus 3 over 2 x2 equals negative 2.05. x1 is then 3 over 2 times x2 minus 2.05. 3 over 2 times this negative 65.96 and then minus 2.05. Okay, let's plug this in our calculator. So we have our answer times 3/2 is like 1.5 minus 2.05. Oh, the answer is negative 101. So far, so good, everybody. Alright, so what is our solution? x1 is minus 101, x2 is negative 65.96. Repeat it. Woo! You see, we just changed a little bit in the B, but our solution changed a lot. See, minus 1 2/3, but now we have minus 101 and minus 65.96. Wow, it changed a lot. So we know that A is very sensitive. To the solution in A is very sensitive to the small change in the parameters. So matrix A is ill-conditioned. But let's find out the condition number. Okay, so we expect to see a large condition number. So let's calculate it. Okay, so here we say since the solution is very sensitive to small changes in the parameter. So the B we can say is parameter. Okay, that defines the problem. So A is ill-conditioned. And let's calculate its condition number. That is the L1 norm of A times the L1 norm of the inverse of A. Okay, so what is the L1 norm of A? Well, that is the maximum of column sum. Right? And what is A? What's the column sum of A? See? 2 plus 1.999. 2 plus 1.999 and 3 plus 3, right? 3 plus 3. So who's bigger? 3 plus 3 is 6. So 6 is bigger. Okay? And next, we need to compute the inverse. Well, how do we compute the inverse? Let me remind you a formula to find the inverse. Okay, so formula to find the inverse is A, B, C, D. The inverse is 1 over the determinant, which is AD minus BC. And then what do? D and A, we switch them. So D is here, A is here. B and C, give a minus sign in front of it. So this is the inverse of a 2 by 2 matrix. Okay, so now let's continue. A inverse is then, by the way, let's calculate determinants. Okay, so what's determinant of A? So keep in mind, A is -2, -1.999, and then 3, right? So that's -2, -1.999, 3, right? And then the determinant -2 times 3 minus negative become plus 1.999 times 3. Wow, that is the same as -0.001 times 3, so -0.003. Right? So A inverse of A is 1 over the determinant minus 0.003, and then A and D switch. So -2 goes here, 3 goes here, and then B and C give it a minus sign in front of it. So it become -3, here become 1.999. So far so good, everybody. Okay, so let's see. If we use 3 to divide by -0.003, we will get -1,000. If we use -3 to divide by -0.003, we get 1,000. If we use 1.999 divided by -0.003, let's figure out what it is. This one I need a calculator. 1.999 divided by 0.003. Oh, we get -666 and 3. The 3 repeats. So far so good, everybody. And -2 over -0.003 is the same as 2 over 0.003. 003. Oh, 666, and then 6 repeats. 666. 6 repeats. So far, so good. Then, what's the L1 norm of the inverse? Well, sum of the column sum, right? Maximum of the column sum. So 100 plus 666.3, so it's 1666.3. And then that one is 1666.6. Of course, the bigger one is 1666.6. Right? And furthermore, so condition number is 6 times, this is 1666.6. Well, what is that number? Okay, so that we have that answer plus 1000. We get 1666.6 repeated. Use this answer times 6. Oh, you see? 10,000. And this is so large. Okay, so condition number is large. Then we get the matrix A is ill-conditioned. You can also try to compute the condition number using other norms. So I strongly recommend you to do that. Okay, so after class, please try to compute the condition number for L infinity norm and the Euclidean norm. Okay, so please do that. And the number you get should be large, but they might not the same as the 10,000. So far, so good, everybody? Alright, let's continue. So, example 6. Find the condition number of this matrix. What happened to the condition number as n goes to infinity? So, this example, we have a parameter n here, right? Okay, so let's see. First of all, we want to let's compute the L1 norm, right? Let's use L1 norm to define the condition number. So L1 norm is the maximum of the column sum. Let me write it down in K. Column sum. The columns 1 plus 1 over n, 3 plus 0. Think about it. N goes to infinity. Well, then this number is very small. Okay, so 1 plus a small number is like 1 point something. Of course, it's less than 3. So the maximum is 3. So far, so good, everybody? Okay, next we need to compute the inverse. Well, let's first compute the determinant of it. So determinant cross multiply, but we subtract 1 times 0 minus 3 times 1 over n. So the answer is minus 3 over n. Right? Then A inverse is 1 over the determinant minus 3 over n. And then we have the matrix. A and D switch. So 1 goes here, 0 goes there. B and C, put a minus sign in front of it. Minus 3 minus 1 over n. Okay, what is this? Well, this is the same as we multiply by n over 3 with this matrix. Okay, 0 times whatever is 0. Minus 3 and minus 3 cancel. We have n minus minus cancel. Oh! And also cancel. So we get 1/3 here. On the other one, we have minus n over 3. So far, so good. Okay, what is the L1 norm? Maximum of the column sum. So 0 plus 1/3 and n plus n over 3. Remember, it's the absolute value of the entry. So that's why we have plus n over 3. Okay, think about it. N goes to infinity. So this is large, right? So it should be n plus n over 3. This is the same as 3, and then we have 3n plus n. So 4n over 3. So far, so good, everybody? Okay, let's continue. So, finally, what do we get? We have our condition number is the L1 norm of A times the L1 norm of the inverse of A. So that's 3 times 4n over 3. The answer is 4n. Now, what happened when n goes to infinity? Well, that is the same as the limit when n goes to infinity of 4n. Of course, this guy is going to be infinity. Okay? So, we know A is ill conditions if n is like getting larger, larger, larger. Right? Because our condition number is getting larger, larger, larger. So far, so good, everybody? Yeah, so we can say A is ill condition when n is large. Okay. So far, so good. Let's continue. Okay, so example 7, I hope you can pause the video here and try to work on this problem first. And then after you're done, you can continue to play the video and check your work. Okay? Are you done? All right, let's see. Okay, so let's say this is A. What is L1 norm of A? You can also use L infinity norm to compute. Okay? So L1 norm is the maximum column sum. So it's the maximum of 1 plus 1 over n and then 3 plus 1. Right? And when n large, this is just a decimal number, right? Very small. So this guy is like 1 point something. Right? 1 point something. Okay, let me don't use something there, right? And this is 4. Of course, the maximum number is 4. And then next, we want to compute the inverse. So let's compute the determinant. So determinant is cross multiply 1 times 1 minus 3 times 1 over n. So it's 1 minus 3 over n. Let's see. Let's take the common denominator, that's n, and then we have n minus 3. So far, so good, everybody? Okay, then A, inverse of A is 1 over the determinant. 1 over that number is the same as the reciprocal of it. N over n minus 3, right? And then what do? A and D interchange, switch, but they are both 1, so they're the same thing. And then B and C put a minus sign in front of it. Well, let's multiply n. We get n over n minus 3. Here, n and n cancel with minus 1 over n minus 3. There we have minus 3n over n minus 3. Here we have n over n minus 3. So far, so good, everybody? Okay, let's compute the L1 norm. Okay, because we're working with this variable n instead of a number, so you have to be very, very careful, especially when you want to determine which number is larger, then you have to be very, very careful. Maximum of column sum. So the column sum are n plus, not minus, because we're talking about absolute value, right? 1 over n minus 3, and then we have 3n over n minus 3 plus n over n minus 3, because we're talking about absolute values. Okay, now let's see what happened. Oops, sorry, I forget. I forget n minus 3 here. Okay, so this is the maximum. You can see the denominator, they're both n minus 3. We can combine them actually. So this is 4n over n minus 3. Okay, when n goes to infinity, which one is larger? So remember, for a polynomial, when n goes to infinity, you just look at the dominant terms. The dominant term here is like n over n, so this guy will goes to 1, right? And the dominant term here is 4n over n, so it will goes to 4 when n goes to infinity. So that's why this guy is larger. So the answer is 4n over n minus 3. Is that okay, everybody? Okay, let's continue. So keep in mind, if you have questions, please print screen and then you can ask me in class or in my office hours or send me an email. Okay, so condition number equals L1 norm of A times L1 norm of the inverse of A. So that is 4 times this 4n over n minus 3. So that's 16n over n minus 3. When n goes to infinity, what happened? See? We have polynomials, rational functions. Then we look at the dominant terms. So this is the dominant terms. So this is the same as limits 16n over n, right? And cancel. So the answer is 16. So far, so good, everybody. And 16 is not large, okay? So this is not large. Compared to our last example, we have 10,000. Now we only have 16. So A is not ill conditioned. And you can see, oops. You can see here, actually this number does not depend on n, okay? Yes. So it's a fixed. No matter how large n is, we're gonna have the limits. The limits of the condition number is a constant. So far, so good, everybody. Okay, now we have talked about the condition number. I'm gonna go ahead and talk about how to use MATLAB to compute. All right. So last video we talked about how to use MATLAB to compute the norms. Well, the condition number, the syntax is C equals condition of A, COND of A. But if you want to use other norm, you can just use norm L1 norm of A times L1 norm of the inverse of A, or you can use L2 norm of A times the L2 norm of the inverse of A, or L infinity norm of A and the infinity norm of the inverse of A, or the Euclidean norm of matrix A times the Euclidean norm of the inverse of A. And you will get the same answer. See? After I type this matrix into MATLAB, when I click OK condition number, you see it's 4. Alright, and let's see here. Oh, okay. So this is the matrix. Okay, so this is the matrix, and if we use L1 norm to compute, the answer is 9.3750. And if we use L2 norm to compute, and we get 3.9803. If we use if we use infinity norm to compute, it's 7.2857, and if we use Euclidean norm to compute, it's 5.2553. And sorry, our condition, K max is for this is just within the calculations. Our condition number is this guy, 9.3750, and that's matched with the L1 norm definition. Okay. That's why we usually use L1 norm to compute the condition number. So far, so good, everybody? Okay, let's see here. Why don't we compute, let's check our example, okay? Let's check the answer in our previous example. Okay, so let's get back to our example, and this is octave, okay? And let's input A equals the matrix -2, 3, and -1.9993. Okay, so if we use if we use L1 norm to compute, then we do norm of A1 times norm of inverse of A1. We get 10,000. That is what we have before, right? And I asked you to check the other norms at home, but now let's do it. Now you can still compute it, okay? And then after you're done, you check whether your answer agrees with what we have now. Okay, so let's use our infinity norm to compute. Ooh, we still have 1,000. If we use L2 norm to compute, let's see what happens. Okay, we got 8,665.3. Okay, if we use the Euclidean norm to compute, let's see what happened. Okay, in this case, L1 norm and infinity norm will give us the same number, and the L2 norm and the Euclidean norm give us the same numbers. But we can see they are very large. So because our A is ill conditions. But in general, all those different norms could be different, right? Just look at the example we did. See the example we did using MATLAB. The four norms, they're totally different. Okay, but they are either all of them are large, then A is ill conditions, or all of them are not very large. Okay, what is large, what is small? I would say 1620 is not large, but 1,800 I think is large. Okay. All right, so that's it about session 3.4, and in the chapter 3 we only cover 3.1 and 3.4. Okay, so in the next class we will talk about chapter 4. So we just pick some sessions in each chapter to cover in our course. All right, so don't forget to do your homework. Have a nice day. Bye.